We go full circle. In the morning, you already saw a now familiar face that belongs to Frederik Braun, or Freddy for short. He was chairing the first session, and now he's giving the last talk of the program until there's the closing, obviously. And yeah, Freddy studied at Ruhr-Universität Bochum a long time ago, not such a long time ago, and wrote his thesis about the same origin policy from then an attacker perspective, and later on moved to the defender side, where he's working for Mozilla nowadays, and is going to tell us a bit about what kind of cross-site issues you can occur and how you can fix those. Obviously, hopefully.
Feel free to keep talking, it's still loading.
Everything is loading. Yes, this is interesting. This is Google is at fault, not Mozilla is at fault, so we can see, or the Wi-Fi is at fault.
No, it was just disconnected, yeah, the
Wi-Fi is yeah, but here we are, going again, and the percent of you, that looks better. So give a round of applause to Freddy.
All right, thank you. Hi, everyone. Today I want to talk about cross-site leaks, which are somewhat new attacks that has been recently in the spotlights. Some defenses that have been introduced in response to that. And I also finally want to answer the question why web security best practices are always opt-in. And, of course, how you can get increased security defenses for your web page. So my name is Frederik Braun. As previously mentioned, I've worked as a security engineer, hacker, teacher for over 15 years, and today I work as the manager of Firefox security engineering. What I want to start today is the HTML design principles that were sort of written by folks in the W3C when the HTML5 rewrite began, which is now, I don't know, 10 years ago or something. Which is really interesting because it's somewhat guiding and also foreshadowing about the question about security being opt-in. And it basically says here, when considering change to a legacy feature in HTML, we always need to look at the cost for breaking existing content. So basically the promise of the web is that web pages written in the 1990s should, to a certain extent, still work today. And that is a challenge. And in fact, it is so far a challenge that it is sometimes more desirable to standardize and improve something that people are widely using, that we would rather not have them use rather than remove something. To add a bit of color to that, I brought an example. I think a great example is the XML HTTP request API. Who here has heard of XML HTTP request or maybe used it? Okay. Though I do see a lot of hands, I'm suspecting that you're maybe not actually using it for XML. And XML HTTP request was sort of retroactively standardized on top of a feature that Microsoft introduced in Internet Explorer 5. So they created a proprietary ActiveX control that allowed certain web pages in IE to make HTTP requests, and people realized this is actually really neat. But it was proprietary, ActiveX, Windows, Microsoft only. So retroactively, there was something standardized that sort of behaved exactly as that API because it was so popular, and that's why it's also called XML HTTP request, which is still sort of a way to do HTTP requests from a web page. And we do have a different function right now, which I suppose many of you know. Does anyone know what the kind of new function is called to make HTTP requests? Yes, I heard fetch. That is very correct. And you know what? We've had fetch for more than 8 years now. 8 years. So, but browsers still support XML HTTP request, and they will likely keep doing so for a very long time. What I mean to say is that the real world is always going to lag behind best practices when it comes to web development and web security. And that means whenever you want to protect your website against recent attacks, you need to opt in. Which brings us to the topic that I brought here today, which are the so-called XS leaks or cross-site leaks. And we're going to see some sketches of attacks. And many of the attacks that we will see are a bit more on the theoretical side because they heavily depend on website behavior. So they are not like a specific bug you can put everywhere you find like a form control or an input element or something. But instead, we're going to look at a lot of APIs that are very widely used and can be used as attacks sometimes. A typical example would be timing attacks. So cross-site leaks really happen in the gray area between this API is sort of like universally used, and oftentimes it's super benign, super helpful, super okay, but it might also be totally and catastrophically insecure for some web pages. And as you will probably guess, that is hard to secure. I'll bring another example, which is pop-ups. As many of you will likely know, web pages can open pop-ups, and the return value of the window open function gives you a handle to the pop-up that you have opened. In turn, the pop-up gets a reference to its previous window, the so-called opener property, which is available as a global variable and also a window handle. And if the pop-up is same origin, then there is a white axis. You can modify, document, redirect, whatever. Both can do anything with each other because they are same origin, and the security boundary of the web is an origin, so that's fine, right? For cross-origin pop-ups, the situation does look quite different. Access is very restricted. You can't do a lot, but some things are still leaking. And what we're seeing here, for example, is that just the number of frames in each of those windows is accessible across origins. And we may think, yeah, is this even like a problem, right? It seems so absurd in one time and also so useless in the other time. But what we've actually seen across the web is that for a lot of web pages, the amounts of frames being present or not present can be used as a login detection mechanism. So imagine attacker.example.com is opening a pop-up for a social network and can basically detect whether the user on the current page is logged in with that social network. And there was a research paper from Lukas Knittel and others who found that out of the top 50 web pages, they could easily detect if the user was logged in. Which, as you know, browser history leaks are a problem, login leaks are a similar problem. That's something we would actually like to avoid. And it's not just frames. So there was a different research paper by the same authors where they tried to find all kinds of leaks in the web platform, how it's supposed to work, how the web is supposed to work. And they found that there are countless ways to leak stuff that might be sensitive depending on the application. And for example, you can leak HTTP status codes, response headers, the amount of redirects that a URL is going through, the length of a URL, and so much more. And really, the corner piece for all of these leaks is just how the web works, right? We do want to embed images from other origins. We do want to use iframes oftentimes. We do want to use pop-ups. So in essence, there are a lot of cross-site leaks out there. And they use very popular APIs that we, as people who secure the web platform in standards and in browsers, can't easily change or modify without breaking existing content. But let's take a step back. How would we secure an API? Like if we were to undergo a really complicated refactoring, let's imagine a web application, maybe multiple microservices talking to each other using different APIs across different components. What we would usually do when we change a bad API and replace it with a better one is we can follow sort of the same few steps. First of all, when you want to remove a function from your code base and replace it with a better one, you start by providing a better one and telling everyone, hey, you should use the better one. Anyone who's been working in software for a long time in like practical bigger teams, you know, asking nicely doesn't get you very far. So now you have two functions. The next step that you can often follow is you disallow usage of the old bad insecure function in new code. What you would do is some sort of static analysis, maybe a linter rule in JavaScript, and you would say all new code that intends to call our bad function is not going to be landed, is not going to be committed. And at that point, you have a really nice control function, because now you have a finite set of bad calls for this specific API that you want to remove. And you know if you're plotting like a line graph, it can only go down, right? Because you disallowed all new usages. At this point, this is a battle that can actually be won. And in many steps, you can switch all existing code to a new API. And depending on the complexity of the problem and the size of your organization, this can take a long time. But the nice thing is, it is finite. At some point, you will be done. You can parallelize this. If it's a massive project, you can do it as a team. Eventually, you will seek code review from lots of different people. Eventually, you will maybe find corner cases that the new API isn't really covering, and then you can iterate. But at some point, you will not find new usage of the bad API, and you will remove all existing ones, and you're done. And you can remove the bad API, which is nice, which is how you would want to refactor bad stuff. Now let's walk through these steps and consider how would we do this on the web, right? Sure, we can add a new API. Look at the example XML HTTP request fetch, right? There are two APIs. But what is new code? We can't disallow new code from being written in a way that we would not like it to be written. Thank you. So basically what you can do is, one, in the developer tools, like give presentation, like I'm giving a presentation here. We can basically only discourage and warn. We can't actually prevent. So this is sort of high level, theoretically, not a battle you can win, right? Because it's not a finite set of bad websites you want to eventually migrate to something better. People just keep using these bad practices. And obviously, we can't rewrite other people's code, right? The next step is rewrite all of the existing code. We can't rewrite the web, which is kind of nice, right? There is no one who can rewrite the web. Everybody can, take part and make a web app. That is really cool. We like that. But we can allow websites to opt out of specific behaviors. So sort of we can think of a way, and I think lots of security headers basically go in that direction, where someone who wants to write a website according to best practices sets some sort of HTTP response header, and then browser behaves a tiny bit differently. And then what we usually do in the web standards community and browser community, and then we do advocacy, maybe for really, really bad big websites that are important, we can do specific outreach and tell them, hey, we observe that this is not ideal. And then we can wait, but eventually we may never actually remove the bad thing from the web. However, I believe there's hope. I believe that with small individual actions, figuring out how to secure specific websites step by step, and talking about this, we can secure the web gradually. And a typical, really simple example, going back to the pop-up case, is a security header called cross-origin opener policy, where in the simple case, same origin access, is still working exactly as intended. Everything is fine. You can still use pop-ups in the kind of scenarios that you may want to use pop-ups. But using cross-origin opener policy as a response header, the return value for window will be a closed window without any kind of access, and the opener property on the window will just be null. So that is a relatively simple one, but that's not all kinds of cross-site leaks, obviously. Some leaks are still possible without pop-ups by just a website embedding stuff from a different website. So now we may wonder, how can we prevent our web page and its content, some sort of assets, from being embedded on another web page? And there is actually also a new security header that you can use, which is called cross-origin resource policy, where you can say, my content should just not be embedded across sites. And then all of that will fail. But maybe, as you know, security controls are somewhat like allow all, allow none, and there is something in between, and maybe you want to have more granular control. There's also something for that. which is called fetch metadata request headers. We'll go through this slowly. As many of you know, if you do an HTTP request using something like curl, it's really just these 4 lines. It's a GET request, there's a host, a user agent. That's an HTTP request. I don't know if you've recently looked at an HTTP request issued by a browser. It doesn't fit on the slide. And that is going to be really useful. And we're going to zoom in here to focus on what I want to talk about today. These are the sec fetch headers, and they add a lot of meta information about what the browser is actually intending to do with the request that your website, your web server is seeing. The first example, the destination header, is going to give you detailed information about how the browser was triggered to fetch this specific URL. So the browser is going to tell you, hey, this is coming for an audio element, image element, script element, whatever. The mode header is going to tell you whether this was a navigation, so whether the user clicked on a link and wants to visit the next site, or whether this was a CORS request or just a no CORS inclusion, which is the default. And the site header is going to tell you whether this is the same site or a cross-site request. So you can use all of these controls to make a really granular decision somewhere on your web server that is actually quite detached from all of your application logic, right? If you just know that certain URLs are not to be reached from other pages, you can just block them immediately when you see the request coming in from a browser. And I think this is going to be really powerful. So if you have a CDN like assets.example.com, then it's probably fine for that to be used on example.com. And if it's used on an attacker page, you can apply these fine-grained controls to disallow scripts, iframes, but maybe allow images. Again, in the spirit of hope today, you can build your own protections, and it's actually relatively simple. And I've brought a tiny demo. I hope you don't shy away from me showing you a bit of code at 5:20 in the evening. But we'll do this anyway. So there's this page, no frames on web security plumbing. And as you will very easily see, you don't, I know I'm zooming. There's a tiny red balloon. Let's consider this our asset, because balloons are sensitive and we don't want them to pop. So, and now let's pretend there's a really, really sensitive thing, and an attacker would like to include it in their page, but they shouldn't. So this is sort of like JS Fiddle or CodePen or whatever. It's called Live DOM Viewer. Doesn't have ads, so I like that. So we're going to use that URL in an iframe. And actually, before I do that, let's quickly open DevTools and zoom in for a bit, because otherwise you're not going to see anything, and that would be sad. I think that should be fine. Is that somewhat legible? I see people nodding. Thank you. OK, so that's not really useful source code. Here's the network thingy. I think we can zoom that in as well. Excellent. So the demo worked fine on my machine, but then I didn't have to watch at the screen behind me. So, OK, and now my web page is reacting with an error message that says the web page cannot be embedded via iframe elements. And looking at the request headers, we can see, I hope that's also somewhat readable. We see that the sec fetch dest header is actually saying, yes, we are using an iframe, we are navigating the iframe, and it's a cross-site request. And if we were to use something else, because we're cool hackers and we know all the kind of inclusion methods, we use an embed element, and then we'll actually react and say, yeah, embed is also not allowed. And we could continue with frames and object and so on, but I'm going to spare you the details. Instead, I'm going to give you a quick skim of the source code, not because we want to read source code together, but to give you an indication of the complexity of this mechanism, which is supposed to be very low. I wrote this in PHP because it's simple to prototype, but you can imagine it working somewhere else. I'm getting all the headers. I'm looking whether there's a segfetch dest header. If there's no segfetch dest header, I say, OK, exit. This is probably not actually a browser. I want to talk to browsers. And then I look at forbidden destination and exit with a different message depending on the destination. Obviously, if you were to protect your own web page, you would build an allow list and not a deny list. But for the sake of this demo, that's what we get. So going back to the slides. Oh, and by the way, this kind of thing where you deny things based on segfetch metadata is also widely known as, or not widely, but also known as resource isolation policy, and I have some links for some guides in my slides later on. Closing thoughts. The main thing I really want to say is if you want to work on web security, you have to opt in. That's going to remain a thing, I'm afraid. So. But again, there is hope. You can build your own protections, and I believe you can build them relatively easily. Thank you. And I believe there is time for questions. Oh, a pop-up. By the way, if you want to see the slides, there's a QR code.
Right, there is time for questions, and we have one question over here.
Hi, I've got two questions, in fact. First question is, does or do Firefox containers inhibit the leaks?
Yes, it depends.
All right, so not really.
Well, so the feature you're talking about, Firefox multi-account containers, is where you can have multiple tabs in different...
Yes, the one that you have.
The one I'm using, yeah, it's really nice, by the way. So I'm going to quickly, for a minute, talk about Firefox containers so people know what's going on. So there's an opt-in extension called Firefox containers, and then you can have differently colored tabs which share sort of like different profiles, and then the cookies between work and social are not shared. So basically CSRF attacks or other kind of side channels between a social container and a work container, they are not shared. So cross-site leaks across containers are not possible. But obviously, if you go to an attacker page in your work container and it's attacking your work website, then yeah.
All right. And second question is, if I'm watching a video on Firefox and I pop it out, like it makes a pop-up.
Yes.
Does that count?
Yes.
Does that pop-up also leak data to sites? Does that pop-up count as a real pop-up?
It doesn't count as a pop-up. And I'm not entirely sure whether websites will be actually aware at all that the video has been shown as a pop-up or as a picture-in-picture. Okay. So I would say it shouldn't leak.
Okay, there's one more question.
Yeah, thanks a lot for the talk. Basically, I have two questions. I find it very often very hard to explain to developers why they now have to implement new HTTP security headers. They had X-frame options, content security policy. Now there's kind of a new thing. So what is your kind of idea how you can get more acceptance of the developers? Because for them, it very often leads to a lot of work. So that's kind of the first question. And the second one would be, is this already implemented in other browsers as well? Or how do you achieve this?
Let me answer the second question first because it's simpler. Yes. These are web standards. We work with other browsers in the W3C, in the WOT working group, etc. These are all standards. All browsers are able to work with cross-origin opener policies, segfetch metadata, and so on, for years, actually. The other question is, it's tricky, right? especially when it comes to security improvements, like you also mentioned CSP, it always heavily depends on the application, right? None of those things would work by just flipping the default and figuring out what's broken on the web, because it's also hard to argue around the whole web. So I'm afraid I will have to weasel myself out with a typical security engineer answer. It depends on your threat model.
Okay, do we have further questions? Yes. Stay.
Thank you for the talk. It made me thought of a keynote I saw from Mario Heiderich in Amsterdam, 2019, I believe, which was very kind of funnily predicted that at some point the length of the security headers gets longer than the body. And at some later point, you can resist on body completely. You will just keep security headers. Is this the way to go forward, to add more and more headers? Or are you thinking as a browser vendor of some alternative measures?
I think like the development life cycle of the web is complicated and very long. If you want to get increased protections now at the security header, ideally we would switch the defaults, deprecate, actually remove some APIs, for which there are examples of where the web community managed to deprecate and remove stuff. We're not going to do that with pop-ups. And yeah, I think eventually we will flip some defaults. We will make some tough decisions, as some browsers have with same-site cookies by default being lax and so on and so on. But it takes some time. And if you want to protect against something in particular, you can opt out. And maybe you want to see that as a hassle and stricter and problematic. But I think there's also value in, being able to make use of these increased security things.
Okay, and with that we are out of time, but I guess maybe Freddy sticks around for a minute or two before he leaves for the train. Maybe. It depends on Deutsche Bahn. So give another warm round of applause for Freddy.